All right, let's talk about solving compound inequalities. Today's lesson, we're going to learn how to write and graph compound inequalities, how to solve them, and how to use them to solve some real life problems. Okay, so what is a compound inequality? It's an inequality formed by joining two inequalities with the word and or the word or. So there's two kinds. First, we'll talk about the and. The and kind of compound inequality is the intersection of the graphs of the inequalities. So it shows the numbers that are solutions to both inequalities. So if you get one that says x is greater than 2, it looks like this. Solid circle at 2, and then arrow to the right. If you're looking at just x minus 5, it's an open circle at 5, and then arrow to the left. If we want to talk about the compound inequality, and you can see there's two ways to write this compound inequality with an and. If 2 is less than or equal to x, meaning x is greater than or equal to 2, and x is less than 5, then it's just these numbers from 2, including 2, all the way up to 5, but not including 5. And so there's two ways to write it. You can write it, and actually you could write it x is greater than or equal to 2, and x is less than 5. Or you can write it as what we call an in-between statement, which is this guy down here. 2 is less than or equal to x, which is less than 5. So that's the and, that are the intersection. Then we have or, which is the union of the two graphs. So if you have y is less than or equal to -2, that looks like this, a solid circle at -2, arrow to the left. If you have just y greater than 1, that's open circle, arrow to the right. If you have y is less than or equal to -2 or y is greater than or equal to 1, then the solutions to this compound inequality are either over here or over there. So anytime you have the word or, you're going to have two sections of graph. Anytime you have the word and, it just should be one section and filled in between two values. So the and, the intersection, can be thought of, it's all the solutions between two numbers, and the ors is all the solution outside of two numbers. Okay, so those are compound inequalities. So let's look at some examples where we're going to write each sentence as an inequality and then graph that. So the first one, A, a number x is greater than -8 and less than or equal to 4. So x is greater than -8 and less than or equal to 4. So x is less than or equal to 4. So there's the and way to write it and the in-between statement way to write it. And sometimes the in-between statement way is easier to see once you've graphed it, or maybe the graphing is easier to see once you write the in-between. But basically, you're going to take, if you have an and statement, you're going to get the smallest number all the way on the left. So -8 is the smallest, so we'll put that all the way on the left. And then you'll put the x in the middle, and then the biggest number all the way on the right. And then in between the x and the -8, we're going to put the sign here, but it's pointing at the -8. And then here we just write it the same because the x is on the same side. So this is the in-between statement way to write it. -8 is less than x, less than or equal to -4. And the way we would graph that is open circle at -8 because it can't equal -8. Closed circle at 4. And then x is all the numbers in between them, including 4, but not including -8. So B gives us a number y is at most 0 or at least 2. So y is at most 0. That would mean the biggest it could be is 0, but it could be smaller than 0. So that's less than or equal to 0. Or at least 2. So it could be 2 or it could be more. So that's y greater than or equal to 2. So you can't write an in-between statement with or. You can only do that with and. So here, with an or, we're just going to graph the two things. Y is less than or equal to 0. So solid circle at 0. Arrow going to the left where the numbers are less than 0. Or y is greater than or equal to 2. So a solid circle at 2. Arrow to the right where the numbers are greater than 2. So when you have an or, your solutions are either over here or over there. When you have and, it has to be both, so it's everything in between those two numbers. Okay, so here are a couple of monitoring progress questions for you to practice. Don't forget to show the process. Go ahead and pause, and I'll show you the answers right about now. Oh, I guess I haven't. But I had them. No, D is no more than 0 and less than 10. So no more than 0 means less than or equal to 0, and less than 10, a D more than 0. That's greater than, my bad. D is more than 0. So that's D is greater than 0. Less than 10. D is less than 10. So we can make an in-between statement. That's 0 on the left because that's the smallest number, 10 on the right, D in the middle, and then it's going to be less than, less than. In an in-between statement, they should always be less thans. Sometimes they'll be equal to also. If you look back at our last in-between statement, they're always pointing to the left. Your lowest number is always on the left. Your greater number is always on the right. Oh, 0 to 10, no equal to signs. So for number 1, we get 0 less than D less than 10. And that graph is going to look like this. For number 2, number A is fewer than -6. So A is less than -6 or no less than -3. So if it's no less than -3, that means it can be more than 3, but it's not less than 3. It can equal 3, but not less than 3. So that is A greater than or equal to -3. So A less than or equal, A less than -6 or A greater than or equal to -3. So A less than -6 is an empty circle at 6, arrow to the left. Then at -3, we're going to make a solid circle because A can equal -3 or it can be greater than -3. Okie dokie. All right, example 2, you can solve compound inequality by solving the two inequalities separately, or if you put it together, you can solve by just doing the operation to all three sides of an in-between statement. So if we're solving an in-between statement, like for here we have x, our variable x is in the middle. We just need to get rid of whatever's around x. So what we're going to do, we have a -2, so we're going to do +2 in the middle, +2 on the left, +2 on the right. And that leaves us with x in the middle. 3 + 2 is 5. -4 + 2 is -2. So -2 less than x less than 5 would be open circle at -2, open circle at 5, and draw in between them because that's where the values are bigger than 2, -2, and less than 5. For B, to get x by itself, we're going to need to start by subtracting 1 to get rid of this +1. So we have to subtract 1 from all three areas. -3 - 1 is -4. And we've got -2x, and then less than or equal to 9 - 1 is 8. Now we need to, in order to get the x by itself, we need to divide by -2. So dividing by -2 everywhere. And then we have to remember that when you divide by a negative, it flips the inequality signs. So this is going to be a greater than, this is going to be greater than or equal to. We'll have x in the middle. On the left side over here, negative divided by negative is positive, so that'll be 2. 8 divided by -2 is -4. And now you can see that we have an in-between statement still, but it's written backwards. We have our lowest number on the right and our highest number on the left. So all we do is just write it backwards. So -4. And then our inequality signs need to keep pointing at the same thing. So this one's pointing at the -4, so less than or equal to x, less than 2. So this would be the solution written as a compound inequality. And then to graph it, less than or equal to there. So we're going to do a solid circle at -4, an open circle at 2, and the graph goes between them because it's an in-between statement. Here's one with an or. With an or, you just solve the two separately. So we've got 3y minus 5 is less than -8. And then we're going to solve for y. So add 5 to both sides. Then we have 3y is less than -3. Divide both sides by 3. And we get y is less than -1. Or, then we solve this. 2y minus 1 is greater than 5. So we are going to add 1 to get the -1 away from our y. We got 2y is greater than 6. 2 times y, so we need to divide both sides by 2 to get y. Y is greater than 3. So our solution is y is less than -1 or y is greater than 3. To graph that, open circle at -1, arrow to the left where it's less than that, and then open circle at 3 because it can't equal 3, and then arrow to the right where the y values are greater than 3. All right, here are some more for you to practice. There's the answers. If you have any questions on those, you can ask in class. Last example, solving real-life problems. Electrical devices should operate effectively within a specified temperature range. Outside of that temperature range, the device may fail. How sad. Okay, so we need to write and solve a compound inequality that represents the possible operating temperatures in Fahrenheit of a smartphone. And they give us temperatures in Celsius. But we do have a formula to convert Celsius into Fahrenheit. So what we have right now is the operating temperatures for this phone in Celsius. 0 is the smallest. So that needs to be less than, well, if it's operating temperature, then it can equal 0 and it can equal 35. So less than or equal to degrees Celsius, less than or equal to 35, right? 0 is the lowest temperature it'll operate at, and 35 Celsius is the highest temperature for it to operate. Now what we need to do is replace the C with the formula in terms of F that it's equal to. So 0 less than or equal to 5/9 times the quantity F minus 32. And that is less than or equal to 35. And now we can just start to solve for F. We can't add 32 yet because it's in the grouping symbols, which is being multiplied by 5/9. So we have to get rid of the 5/9 first. So we can start by multiplying by the reciprocal. So we're going to multiply by 9/5. So in the middle, these are just going to cancel out. 9/5 times 0 is 0. Anything times 0 is 0. And then in the middle here, we just have f minus 32. Then over here, 35 times 9 divided by 5. Uh, 63. Then to solve for f, we can finish up by just adding 32. And we get 32 less than or equal to f less than or equal to 95. So that means that the lowest temperature it's supposed to operate is 32 degrees Fahrenheit. And the highest it's supposed to operate in is 95 degrees Fahrenheit. Then B, describe one situation when it could be below the operating range and when it could be above. All right, situation 1, you're in Alaska and it's freezing 10 below 0. Boom, there's a situation. Your phone shouldn't work. How about this one? It's summer in Palmdale where you live and it's 110 degrees. Your phone should not work, or at least that phone. Don't get that phone. Don't get that phone if you live in Palmdale because it's not going to work because it's over 95 a lot. Okay, folks, that's it for today. If you have questions, hit me up in class tomorrow, and we'll do some practice stuff. See you then.